Okay, we are starting on section 8.3, and these are non-linear systems of equations. So up till now, when we were solving by graphing, they were linear. These, we're going to have two kinds. We're going to have linear quadratic, where one's linear and one's quadratic, and then we're also going to have quadratic systems. And just have an idea in your head of what those are going to look like. If I have a quadratic linear, I have a parabola for the quadratic and then a line that goes through it, I can have two solutions. Or I can have where the vertex of the parabola goes on the line and there's only one solution. So this would be two solutions, this would be one solution. And it's also possible that I have no solutions. If my parabola is up here and it never intersects with my line, this would be no solutions. So this is general things that you would look for the solutions to look like. First thing I've got is solving systems. This one I'm going to solve by substitution, and the reason I chose that is the y is by itself. So I'm going to take that and I'm going to plug it in for y in the other equation. So this equation is 2x minus whatever y is equals 7. And my y is x squared minus 2x minus 3. So I'm going to distribute that. This is like there's a negative 1 out in front of here. I'm going to distribute that negative 1. And I have 2x minus x squared. Negative times negative is a positive 2x. Negative times negative is a positive 3 equals 7. I'm going to combine like terms. So I have negative x squared, 2x and 2x is 4x, plus 3 equals 7. Now, we want to set it equal to 0. Whenever you have a quadratic, you want to set it equal to 0 to solve for your x. It's really complicates things when you have a leading negative. So instead of subtracting the 7 over here to set it equal to 0, I'm going to subtract all of these things over to the other side. So I'm going to add x squared to both sides. I'm going to subtract 4x from both sides. And I'm subtracting 3 from both sides. What that'll do is eliminate everything over here, so I have 0, which is what I'm looking for. And as I put these together, I'm going to put them in standard form from biggest to smallest exponent. So I have 1x squared, I have a minus 4x, and then I have a positive 7 and a negative 3, which is plus 4. That's something much more manageable, and we can solve that by splitting the middle, and we end up with x minus 2 and x minus 2. Since those are the same thing, you only have to solve it once. There's really only one solution. So I have x minus 2. Remember, we set that equal to 0. Add 2 to both sides. So x equals 2. That's the only x value solution I have. So now what I need to do is plug this in to one of my original equations. And it doesn't matter which one you choose. I'm going to choose the second one. So I have 2 times 2. Because I'm plugging that in for my x, minus y equals 7. 2 times 2 is 4, minus y equals 7. I'm going to subtract 4 from both sides, so I have negative y equals 3. Divide both sides by negative 1, and y equals negative 3. So my solution is 2 comma negative 3. And I only have one solution in this particular case, which means the vertex from the this is actually going to be the vertex because it's the only point that they share. And then we know that the vertex of the parabola is on the line because we only have one solution. Okay, next one. There we go. Okay, so this one isn't quite as obvious what I should do. And generally speaking, I always want to try and get a variable by itself if I can. If I take this and I just add y to both sides, I have x equals y plus 1. That becomes much easier then to substitute in for for x in my original equation. So my original equation is whatever x is squared plus y squared equals 25. That's that first equation. And what I'm putting in place of the x squared is this expression y plus 1. And remember, when we square a binomial, we can't just square the parts. We have to square the binomial by taking that binomial twice. So I'm going to FOIL these, and if you multiply these out, you get y squared plus 2y plus 1 plus y squared equals 25. Okay, and I FOILed that. I had 1y and 1y, which I combined to 2y just went right to combining the like terms. Now on this side, I'm combining like terms. I have y squared plus y squared. So I have 2y squared plus 2y plus 1 equals 25. Because I have a quadratic, I want to get it equal to 0, so I'm going to subtract 25 from both sides. So we have 2y squared plus 2y minus 24 equals 0. And if you're looking closely, you can see that there's a greatest common factor I can factor out of this. I'm going to take that out because it's going to make my life a little bit easier. And I have y squared plus y minus 12. Now I'm going to split the middle of this, and I get y plus 4 and y minus 3 equals 0. This is also a factor, but when you go to set your factors equal to 0, if I set 2, there's not a variable involved here. If I set 2 equal to 0, it's just nothing, and we don't do anything with it. So I'm going to have y equals negative 4 and y equals positive 3. And the problem is a lot of people want to stop here because they see two numbers and they think that's an ordered pair, but that's not. If you pay really close attention, those are both y values. So now what I have to do is take those y values and plug them back into an original equation. And I'm going to plug them into this equation. So when y equals negative 4, and I plug it in this equation, I have x minus my y, which is negative 4, equals 1. And when y equals 3, I'm going to plug that into my equation. I have x minus whatever my y value is, which is 3, equals 1. This becomes x plus 4 equals 1. Subtract 4 from both sides, and I have x equals negative 3. So this ordered pair is this x value that goes with that y value. That's one solution. My other solution, I have x minus 3 equals 1. I'm going to add 3 to both sides, and I have x equals 4. So in this situation, when my x is 4, my y is 3. This should be a negative 4, right, because I had a negative 4 up there. Those are my two solutions. So the key here is not to stop when I find one variable, because you have to have both variables and put them into an ordered pair. In number 1, I only had one value. This time I have 2. Both of those values have to be plugged back into an original equation to solve so that you get both solutions. So this is going to be something where, and this is a circle, right? Kind of send you back to geometry days. So my options when I have a circle are that line and a line. It can be tangent. That's going to be one solution. My line could go through the circle, which is going to give me 2 solutions. Or the circle and the line don't touch at all, which would be no solutions. This one's going to be one where the line goes through the circle and you have 2 solutions. Okay. I'm going to do one more. I want to get a letter by itself. I'm going to set the y equal to the rest. I'm going to add 1/2 x squared to both sides. So I have y equals 1/2 x squared minus 3. And I'm going to take that value for y, and I'm going to plug it inside the y in this other equation. So this is x squared plus whatever y is squared equals 41. And y is 1/2 x squared minus 3. And if I do that, probably, actually, you know what, I'm going to back up a little bit here. I know you guys love fractions, so I'm going to get rid of the fraction for you first. We could do it the way I was going, but I just know how you people work, and you just don't like fractions. So we're going to go back. First thing I'm going to do is multiply this whole thing by 2. Whenever you have a fraction, if you multiply everything by the denominator, it'll get rid of the denominator. So I have 2y. 2 times a negative 1/2 is a minus 1 x squared, and that equals negative 6. Then if I solve that so that I get y by itself, I have 2y minus x, add x squared to both sides. So x equals x squared minus 6. Okay, I'm going to pause here.